Hi, so this is an exam question. It comes from June 2013, it's paper R, the regional paper, okay? This is question 6. Now, when you read through the question, you might get a bit daunted and think, how do I even start this? What's going on? How do I do this? And yeah, it's the same with the vast majority of vectors questions, okay? You've got to get into a positive mindset. You've got to think, right, okay, I know this is going to be difficult, it's going to be challenging, because vectors is challenging. If you don't find vectors challenging, then you've not thoroughly understood it, okay? Or you're an utter genius, one of the two. But the way to try and work through it is to try and break it up into small bits, okay? I always find it useful to write the stuff down, okay, particularly the vectors question, because when you write it down, it helps you just to get it clear in your head what is what, okay? So it tells us that A has got that position vector. Notice I use the column vectors, okay? Because look, I mean, let me show you. You kind of got a mixture of column vectors and I as JKs. You don't want that, you don't want a mixture. It's like working fractions and decimals. Fractions or decimals, not both. Okay. So that's A, that's B, that's R, okay? Given that point A lies on the line L, find the value of A. Okay, so remember what I said about this here? Your general equation for position vector, okay, with this line here. The top line indicates the x coordinate, middle line the y coordinate, bottom line the z coordinate, or the I component, j component, z component, okay? So what we're saying is if A lies on the line, we can effectively say that that is equal to 21, negative 17, 6, in which case you can say that is equal to that, that equals that, and that equals that. Okay, you've got several unknowns in there. You've got A, B, lambda, C, but it's going to be easier if we look at the bottom line because they've got just one unknown. 10 minus lambda equals 6. And from that, you see, you can work out lambda straight away. Lambda equals 4. Okay, and then, because we want to work out A, let's go for the top line. So you have A plus 6 lambda equals 21. So A plus 24 equals 21. A equals negative 3. Like that, okay. At some point I'm going to write that off and I don't want to forget. Okay, so I'm going to write it up here. Lambda is 4, A is negative 3. Okay, so that's part A of the question done. Next, given also that vector AB is perpendicular to L, find the values of B and C. You've got to read these things at least twice to sort of try and see what's going on. Given also that vector AB is perpendicular to L, there's a lot of things going on there, isn't there? Break it up, okay? It introduces vector AB to you. We don't know what AB is, so we've got to work it out. Let's do that first. So AB, there to there. So that's going to be 21 plus 4, it's going to be 25, negative 17 plus 3, and 6 plus 12. Yeah, so AB is that, 4, 3, 12, okay? It's perpendicular to L. Now, anything to do with angles, you use the scalar product. Okay? Anything to do with angles, use the scalar product. Okay, do you remember what the scalar product is? So it's this, A dot B, isn't it? And that's mod A, mod B, cosine theta. That's the scalar product. Okay? What about the perpendicular bit? That means theta is 90 degrees, isn't it? Okay, perpendicular, theta is 90 degrees. So what does that scalar product become? That times that, cos 90 degrees. Cos 90 degrees is 0, so scalar product is 0. Do you remember that fact? I kind of introduced it the other way around. The other way around I said if A dot B is 0, what does that mean? It means the lines are perpendicular. Okay. So nowhere in the question does it mention a scalar product, but you have to use it for that there, okay? So the lines are perpendicular, the vectors are perpendicular, so that means the scalar product between the two is 0. So that means the scalar product between AB, 4, 3, 12, and the other vector, which I'm not going to mention at the moment, is equal to 0. Okay. And what's the other vector going to be? It says it's perpendicular to line L, so we need to choose a vector from line L, which is this, isn't it? Okay. Need to choose a vector from line L. Which one do you go for? Okay. Which one do you go for? While you're thinking about that, let me just rub the board, make some space. So let's just say that's line L. Okay, let's just say it's AB. Look at that, they're perpendicular. Okay, so we know that here's a hint for you. We know that the direction vector AB is that. we need the direction vector of L. Which is the direction vector? Okay, that's the direction vector, isn't it? Yeah, that's just a position vector that lies on the line. That's the direction vector. Okay, if you've forgotten about that, go back to your notes earlier and write down where you had this. Okay, that there is the direction vector. Okay, because when you're taking the scalar product, you take the scalar product between the direction vectors, not the position vectors, because that's basically points. You don't find angles between points, you find angles between directions. Okay, so the direction vector is this, 6c negative 1. Okay, 6c negative 1. Okay, not the lambda bit. Lambda is just a scalar multiple, because the direction vector is like that. That's for example 6c negative 1. It's a finite vector from there to there, but the lambda then extends it infinitely in both directions, if you remember. Okay. So all of that telling us that the things are perpendicular means that that dot that equals 0. So what that means is we're going to do 4 times 6 added to 3 times c added to 12 times negative 1 equals 0. Okay, so that means 3c is equal to negative 12, so that means c is equal to negative 4. I'm going to write that up there. Okay, so c is equal to negative 4. Okay, now the question says use that fact to find the values of b and c. Well, we've just found what c is, haven't we? So we need to find what b is. How do we find what b is? Well, remember earlier we equated the top row and the bottom row. We've not looked at the middle row yet, have we? The y components. Okay, so let's look at the middle row. So b plus lambda c equals negative 17. Okay, and thank goodness I wrote down those things there because I'm going to need it, aren't I? So b, then lambda c. So 4 times negative 4. Okay, so it's negative 16 equals negative 17. So b must be equal to negative 1. Let's write that there as well. Okay, I hope that made sense to you. Right. Before I run off, let's read the next part of the question. Find the distance AB. It's pretty easy, okay, because look, you know already what A and B are. Okay, so even if you couldn't do any other part of the question, you can do that. The distance AB. That's just Pythagoras' theorem, isn't it? So I can rub this off now. Don't need that. Don't need any of this. Okay. So the distance AB. So we can write that like this. That's AB. And the magnitude is the distance. So what's that going to be? I've rubbed off the vector AB, haven't I? Well, if you've still got your AB, you just use that, okay? But I'm going to have to do it again. So anyway, it was 4 squared and then plus 3 squared plus 12 squared. Okay, isn't that lovely? Isn't that lovely? Why is that lovely? 144 plus 16 is 160 plus 9 is 169. And root 169 is 13. That's why it's lovely, because it comes out to be an integer. Okay, so that's that. Root AB is 13. The last bit. The image of the point B after reflection line L is the point B dash. Find the position vector of the point B dash. This is the point when people are like, what? Yeah, I don't need that anymore. Okay, that's just a mere, a mere question, just putting there for the sake of it, I think. But what I'm going to need is this, what AB is. So let's just write it down again. So 4, 3, 12, wasn't it? Okay. So let's read the question again for you. The image of point B after reflection of the line L. Draw a sketch of what's going on. So look, I'm going to put L there. Now L might not be vertical. It doesn't matter. It doesn't matter how you do it. Okay. What matters is the relative positions of points. Okay. It tells you that AB is perpendicular to L. Now let's look at this more carefully. Earlier it said A lies on the line L. Okay, so this is the line L. Let's just put point A there, shall we? Okay. And then it says A to B is perpendicular to L. So let's just put A to B there, shall we? That's perpendicular. Now let's read the question. It says the image of the point B after reflection in the line L. Okay, so you know how to reflect this, okay, through the line. That's the mirror line, that's point B. Reflect it, it ends up somewhere there. I don't have to be terribly accurate, just so you've got an idea, okay. Right, that's a diagram showing us what's going on, okay. So the point B is reflected in line L, and it ends up there, point B dash. Our question is work out what is it coordinates or position vector? Position vector, because there is a difference. Work out the position vector of B dash. Okay, position vector means you've got to write it out like this, basically. Okay. So how are we going to do that? Okay. Well, notice I sneakily wrote that up again. Okay. Now, using vectors, BA is the same as AB dash, isn't it, as a vector? Okay. Now AB is that, so that means that BA in the opposite direction is going to be -4, -3, -12, because it's the negative of AB, isn't it? Okay, but that's also going to be the same as AB dash. So we've got the vector AB dash. We know point A, okay? We know point A, it's that, isn't it? Point A is 21, -17, 6. So the question is, how do you get from point A to point B? That's how. What therefore is point B dash? Sorry, I should have said dash. Okay, you just start with A and then you add on that vector. So -4, -3, -12. Okay, and we get 17, -20, and -6. And that's it as a position vector. Okay, so 17, -20, -6. Just check. Yeah, that's it. It's all done. Okay. So it's kind of an interesting question, wasn't it? Okay, so not sure what you thought about that, but I chose that one on purpose because, yeah, it's just a jolly good example, I think.